All right, so let's talk about now the inverse of a 2 by 2 matrix. So if ever you see this notation, this actually reads the inverse of matrix A, or you could say A inverse. You read that as the inverse of matrix A, or you can say A inverse. Now, the inverse of matrix A, or A inverse, is equal to 1 over the determinant of A times adjoint A. The inverse of matrix A is equal to 1 over the determinant of A times adjoint A. Guys, if A is the matrix A, B, C, D, adjoint A is, all right, so if you have a matrix, to get the adjoint matrix, you're going to switch around the leading diagonal elements. The leading diagonal elements are A and B. You're going to switch them around. The lagging diagonal elements stay where they are, but their signs change. So to get the adjoint matrix, you're going to switch around the leading diagonal elements. You're going to switch around your A and your D. The B and the C stay where they are, but their signs change. Guys, only a non-singular matrix has an inverse. In other words, you cannot find the inverse of a singular matrix. Only a non-singular matrix has an inverse. And the basic reason for that is because you cannot divide by 0. If the matrix is singular, the determinant would be 0, and you cannot divide by 0. Therefore, a singular matrix has no inverse. You cannot find the inverse of a singular matrix. Turn to the page. All right, example 9. In example 9, we're asked to find the inverse of the following matrices. So let me do B. I'm doing B. I'm finding the inverse of the matrix B. Guys, now B inverse, or the matrix B inverse, is equal to 1 over the determinant of B times adjoint B. Now let's go for the determinant of B. Remember, we're going to multiply the leading and the logging diagonal element, multiply the two leading diagonal elements. So minus 2 times 6 is minus 12, minus the product of the lagging diagonal elements. So it's minus 3 times 3, which is minus 9. So this is minus 12 plus 9. The determinant of B is minus 3. So therefore, B inverse is 1 over the determinant, which is minus 3, times adjoint B. Now guys, this is what I said about adjoint. To get the adjoint matrix, you must switch around the two leading diagonal elements. So we need to switch around the minus 2 and the 6. So the 6 goes here, minus 2 goes here. The other two elements stay where they are, but their signs change. So the minus 3 at the top changes to positive 3, and the positive 3 bottom left changes to negative 3. Guys, to get the adjoint matrix, you must switch around the leading diagonal elements. The lagging diagonal elements stay where they are, but their signs change. Guys, multiplying by 1 over minus 3 is the same as saying divide by minus 3. So this would be 6 divide by minus 3. 3 divide by minus 3, minus 3 divide by minus 3, and minus 2 divide by minus 3. All right, so we're multiplying a matrix by a number. Whenever you multiply a matrix by a number, you simply multiply every element in the matrix by that number. But multiplying by 1 over minus 3 is the same as saying divide by minus 3. Therefore, 6 divided by minus 3 is minus 2. 3 divided by minus 3 is minus 1. A positive divided by a negative is a negative. Now minus 3 divided by minus 3 is positive 1. A negative divided by a negative is a positive. And minus 2 divided by minus 2 is positive 2/3. A negative divided by a negative is a positive. So the matrix B square is minus 2 minus 1, 1, 2, 1, 2/3. That is the matrix B inverse. Very quickly, I want you now to find A inverse and also C inverse. All right, so we're to find the inverse of the following matrix. So A inverse is 1 over the determinant of A times adjoint A. Now, the determinant of A is 2 3s 6 minus 1 times 4, 4. So the determinant of A is 2. And so A inverse is 1 over the determinant 2 times adjoint A. Now, for adjoint A, I'm going to switch around the leading diagonal elements. So that's 3 and 2, switch them around. The 1 and the 4 stay where they are, but their signs change to minus 1 and minus 4. Guys, multiplying by a half is the same as saying divide by 2. And so A inverse is 3 over 2 minus 1 over 2 minus 4 over 2 and 2 over 2. And so A inverse is 3 over 2 minus a half minus 2 and positive 1. So this is A inverse. Let's also calculate C inverse. Now, C inverse is equal to 1 over the determinant of C times adjoint C. Now, the determinant of C is minus 5 times minus 2, that's positive 10, minus 3 times minus 3, which is minus 9. So this is 9 plus 9, sorry, 10 plus 9, 10 plus 9, the determinant is 19. So C inverse is 1 over 19 times adjoint C. For adjoint C, you're going to switch around the leading diagonal elements. So this is minus 2 here and minus 5. The minus 5 and the minus 2 change positions. Now the 3 and the minus 3 stay where they are, but their signs change. So this is minus 3 and positive 3. it might look like they switch around, but they didn't. They stay where they are, but their signs change. Now, multiplying by 1/9 is the same as saying divide by 19. So C inverse is minus 2/19 minus 3/19, 3/19 minus 5/19. So this is the matrix C inverse.